Hello class again and welcome to this particular video, and in here we're going to explore a conclusion on our previous video, which involves looking at position time graph, specifically curved position time graph that leads to us to understand more about accelerating objects. And all this comes down to the following based on our analysis of our position time graph. So our position time graph actually produces various interesting curve pattern where this is our position with respect to the measurement in meters, and this is a direction, and this is our time in seconds. And so you have a couple of interesting patterns that are happening here. So we have one pattern in here, we have that is a curve that is actually reaching a particular plateau, which is represented as curve A, and we have another pattern here which shows you a different case scenario where we are having a rapid increase or rate of change over time, which is based on instantaneous pattern, and this is represented as B. And then finally here is another pattern here which shows that it is going in the other direction, where you kick a ball at a particular horizontal velocity and then it just curves down and drops from a specific height. And so this actually shows this particular pattern, which is C. And so based on all these patterns here, you see how are we going to get our velocity. Velocity, take note, is through the instantaneous velocity, which means that the particular slope at each point on the curves actually is the number that we're going to plot on our velocity time graph, and that is going to be done with respect to the time. And so therefore our specific velocity time graph, take note of this, is measured, take note, based on the velocity is in meters per second, and it is going to be pointing in the east direction, and that is our time in seconds. And so therefore where we are seeing curves on our position time graph, we're going to be seeing a smooth straight line that is going to be present in our velocity time graph. And so therefore for our A, what we see is that for our instantaneous rate, we are starting at a very big number of our slope, and we're going to smaller numbers leading to zero, which is going to be shown as this particular pattern all the way down straight line to zero for A. Now for B, on the other hand, here we're starting at 0, and then we are having horizontal slope, and then we're increasing to bigger values, positive values of our velocity, and therefore this is going to be associated with our velocity here, where our lines will be shown, our line will be shown as this particular pattern, and it's showing that it is increasing at a constant rate here. At the other side here, we have our particular C, where on our C we're starting here, which is 0, and 0 horizontal slope is going to be increasing, but it's having a negative slopes but increasing numbers. Therefore in this particular case here for our C, we are seeing this happening where we are going from 0 all the way to bigger values of our negative number, which is going to be represented as our value line, which is C. So these are the two things to keep in mind in here concerning our position time graph to our velocity time graph. And as a result of that, we can come to a conclusion about our velocity time graph to our acceleration time graph, where our acceleration, take note of it, is measured here in meters per second squared. Take note that the acceleration is a vector and is in the east direction, and this is with respect to time measured in seconds. And so therefore we have our specific velocity for a slope to be a constant acceleration, which means that in this case here we are actually having a negative value for acceleration, which is somewhere around this particular region, because it is a negative number for our specific slope of this particular line. For our B, since the value is a positive number, because we have our positive slope, is going to be above the specific t-axis. So that is our B. And finally for our C, since it is a negative number, it means that it's going to be somewhere around A. Now, depending on how steep A is compared to C, that will change based on the position of our specific A relative to C on this particular graph here. But take note that in general, when you have negative slopes for our velocity time graph, our acceleration time graph shows that it is below the t-axis. So that is how you keep this in mind based on our summary on our previous video. And in this video, we're going to come to the conclusions based on some interesting relationships where we're going to look at how do you determine the following. Now, how do you determine the following based on what we are actually talking about and what are the givens based on the graph? So when you're given a graph and you're asked to determine a particular variable, what do you do? Now, based on this, do you do the following? Read the information from the graph, or do you take the slope of the graph or of the line, or do you take the area of that particular graph? So here are a couple of things to keep in mind. First is that when you're asked to determine the position of an object, we're going to use the particular variable, which is the d with the arrow at the top is the vector, and you're given the position time graph versus, on the other hand, here you're asked to find the velocity or average velocity, and you're given the position time graph, or how to determine the velocity again, but this time you're not given a position time graph, but you're given a velocity time graph, or you're asked in this case here to find the same velocity, but this time you are given the acceleration time graph. And another one is when you're given, in this case, acceleration, also when you're asked to find the acceleration and you're given the velocity time graph. And finally is when you're asked to determine the acceleration, but you're given the acceleration time graph. So which one of these three applies to determining position, velocity given the position time graphs? So based on what we know in this case is that, hey, for we to get the position from the position time graph, all we have to do is read the information from the graph. That is pretty much it. So what we just do is look at our specific y-axis, and from our y-axis, we'll be able to get the position through the position time graph. Now, the next one here is for the velocity. How do we determine the velocity given the specific position time graph? And in this case here, we do need to do the slope of our specific position time graph, which means either we do rise over run, which in this case rise is going to be our position and our run is at a particular time, or we do the instantaneous velocity in this particular case. And on the other part here is, what if you're asked to determine the velocity, but you're given the velocity time graph? And how are you going to approach this? Now, to approach this particular situation, all we got to do is just read information from the graph. That is it. Read the information from the graph where our specific y-axis is going to be labeled as our velocity. And at a particular time, you'll be able to generate that particular information. On the other hand, when you're asked to determine the velocity from the acceleration time graph, what you have to do in this case is that, looking at the acceleration time graph that we have over here, we have to do the area under the curve here for B. In this case, the area under this particular line is going to give us the specific velocity at each point on the velocity time graph. And so therefore, in this case here, we are going to be clicking on our first area ever in this particular case, and the area under the curve is going to give us our specific velocity from our acceleration time graph. And the next one here is when you're asked to determine the acceleration given the velocity time graph, what do we do? In this case here, we know that we have to do our slope of our velocity. In this case, we know that our rise is our velocity over our run, which is our time, and therefore the slope of that particular graph here, which is the velocity time graph, gives us our acceleration. And finally, our acceleration, to find the acceleration given the acceleration time graph, we will have to do the following. Read it from the graph, where in this case, our specific acceleration is going to be labeled on the y-axis, and that is how you're able to analyze and break down key informations that will be determined or will be required in order for you to answer various questions involving curved type of position time graph, or we have our constant acceleration in this particular manner right here. So that's about it for this particular video. I hope you found this really informative. Please hit the comment down below. Let me hear your thought about this. By that way, I can talk to you soon. Stay smart as always and believe in yourselves.